And this is your Geometry Do Now 26.2, and this is your Do Now Geometry Geometry Do Now 26.2, and here's your video keys. So let's see here. I've got a new dashboard that's a little distracting here for my video making, but will persevere. So here we have a new theorem. This is a theorem from chapter 7, section 1. It's an important theorem, and the proof of it demonstrates some really key ideas for how you can expand outside the box, draw extra lines, and make proofs that will be useful going forward in the next several chapters. So I thought it would be worth dwelling on this a little bit. So we have some information below. So in the second diagram, we've got our first diagram, and we've got our theorem. Let me back up. The theorem says a segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay, so here is that segment that is joined by the midpoints of two sides of the triangle, this side and this side. And we are saying that it is parallel to the third side. So the theorem says that HM will be parallel to JK if we plot H and M as midpoints. Now, we also have a secondary thing, which we'll explore in the exit ticket. Its length, the length of HM, is half of JK. That's what the theorem says. But a theorem is something that must be proved. We cannot simply prove it by saying the theorem says it until we've demonstrated the theorem is actually true. So what we know is we know H is a midpoint and M is a midpoint. Okay, so H is a midpoint for GJ and M is a midpoint for GK. And that tells you some interesting things, which we'll explore. We're trying to prove right now the first basic idea of this theorem, that HM is indeed parallel to JK. Within this diagram, we don't have the resources to do that. However, we have the magic of drawing an extra line. And so we drew an extra line. Well, first, we drew a point out here called P, and we extended HM by MP. And MP has the distinction of, we've drawn this intentionally so that MP is congruent to HM. So we know that because we've determined that by the way we drew it. And of course, with constructions, you could just copy the segment and then copy the length of HM and then just extend it. If you used a compass and just worked a circle around here, you could easily extend to be double. So this could be done with the simple measuring tools of a straight edge and a compass. At any rate, the question I've asked, I'm doing this in steps. So in the second diagram, we have extended HM to a point P so that MP is congruent to HM. So what can we say about this? Produces an angle. Okay, so we have an angle that's already there, GMH. What can we say now about this angle that's been produced by this, KMP? Note that we also connected P and K. So what can we say about KMP and GMH? Well, they're vertical angles, so we can say that they are congruent. Okay, so angle GMH is congruent to angle KMP because they are vertical angles. Okay, so that's the first thing. Goes back to, I think, chapter 2.7. Okay, now, given that M is a midpoint, here's a second piece of it, and we're gathering information here. Each of these things builds on the last thing. M is a midpoint. What can we say about the segments GM and KM? Well, if M is a midpoint, we can say that those segments are congruent. So GM is congruent to KM by definition of a midpoint. Okay, now we've already established that, there's my pen. We've established that this is congruent to this by vertical angles. And we've established that this is congruent to this. So this is for 1C. So we've also established this is GM and KM are congruent by definition of a midpoint, and we intentionally drew MP and HM so that they are congruent. Okay, so now in question 1C, I'm going to be asking you, okay, given we've drawn MP to be congruent to HM, and the vertical angles show that GMH and KMP are congruent, and you just figured out that GM and MK or KM are congruent, what can we say about triangles GMH and KMP, and why? Well, we can say that angles GMH and KMP are those triangles. So I'm going to do it again like this. I'm going to copy pasta this. So those are congruent by side angle side. So we can say that triangles GMP and KMP are congruent by side angle side. Okay, and let's see what I have and that's why. Now, once we've proven that these two triangles are congruent, that opens up a bunch of things like angle G and angle HGM and angle PKM are going to be congruent. Also, side PK and GH are congruent. So that gets into our next one. So since the triangles are congruent, since triangle GMH and KMP are congruent by side angle side, what can we say about angle G and angle, so I think angle G, I think I named this one wrong. I need to redo that one. It should be angle G and angle PKM. I'll fix that. But at any rate, what we can say about angle PKM and angle G, let me correct that real quickly. That should be K, that should be PKM. Okay, so I apologize for that. So here we go. We've got angle G and PKM. They are congruent by Kappa-Kadaka. And we can also say that GH and PK are congruent by Kappa-Kadaka too. But we also know that H is a midpoint. Since H is a midpoint, GH and HJ are congruent. And if these two are congruent, then this one is congruent to this. HJ has to be congruent to PK by transitive. Okay, so we can say that angle G is congruent to angle PKM by segment PK is congruent to GH, I'll call it actually HG to keep things corresponding, by Kappa-Kadaka. Corresponding parts of congruent triangles are congruent. Also, GH is congruent to HJ by HJ by definition of a midpoint. And then finally, PK is congruent to HJ by transitive property. Okay, so once we've got that, now we've got opposite sides here are congruent. We also know that this angle is congruent to this angle. Okay, so that's going to tell us that GH and PK are parallel. Okay, so since those two angles are congruent, okay, I named it correctly there, and PK and GH and HJ are all congruent by Kappa-Kadaka, definition of a midpoint and transitive property, we can prove that the quadrilateral PKJH is a parallelogram. And the reason it's a parallelogram is that, okay, so the reason it's a parallelogram is that the opposite sides are congruent. And because angle G and angle PKM are congruent, those are alternate interior angles, which means that this makes GK a transversal for two parallel lines. GH and PK could be extended to be parallel lines. So we know that, so what we know now is that HJ and PK are both congruent and parallel. Okay, HJ is congruent to PK, and the angles demonstrate as the angles G and PKM demonstrate that PK is parallel. That's not parallel. Parallel to HJ. Then we know, so all of that gives us the parallelogram, HJKP. So opposite sides that are parallel and congruent for a quadrilateral make that quadrilateral a parallelogram. So that tells us, so if this is a parallelogram, so we know HJKP is a parallelogram because opposite, parallel, and congruent sides, okay, make a parallelogram. Well, since it's a parallelogram, then that means that JK and HP have to also be parallel, which means HM is parallel. So that means HP and JK are parallel because they're also opposite sides. Of a parallelogram. Okay. Now, I hope that was helpful. I know that's a fairly complicated proof, and if you got some of it, that's great. We'll discuss it more in class, and hopefully it'll all become clear.